Let me share my screen. Oh shoot, that's the wrong one. I didn't put anything up yet. Is that okay, Shirley? Jeez, dang. I guess so. Can you see it now? Okay. Uh, you probably have a Droid, huh? That's probably why. You need to step up to an iPhone. Okay, okay, good. Let's see. Did you make it a? Oh no, no, no. You have to make it a. Try to make it a Google Doc, Marlena. That'll be easier. You have a Google Drive? Oh, you don't have one? Yeah, just upload it. Like go to your Google and then add it as a. Here, I'll do it. I could do it again. Yeah, because I'm doing everything else. Let's see. Gmail. Leave. All right. Let's see. Why is it taking so long? All right. Here we go. So why is it taking so long? All right. Let me kind of try to get started while we're doing it. You guys can still see the worksheet though, right? Okay. You can see mine. Okay. Okay. It's loaded. Hmm. Sorry, it finally loaded. Um, Sharing settings. Holy cow. Okay. Share. My computer's going really slow. I'm sorry, guys. Yeah. You're at the car wash, so you could care less. You're just trying to burn a bunch of time. All right, all right. I went to the car wash yesterday. It took like 2 hours. Done. Yeah, it's ridiculous. Oh yeah, I couldn't go to Target. I went to the one by the school. Okay, so the file is in the chat. So now I think we can officially begin. All right. So just click on it. You should be able to access it, and it should be the PDF version of it. I should have done that before, but okay. So in this workshop, we're going to work on two things. So we're going to work on um, two different types of probability distributions. So we're going to have a distribution. Do you guys know what those are? Remember what they were? Yeah. Take. Yeah, it could be. It could be the z-score table. Um, Let me add a page. So here's the idea, right? So for a probability distribution, um, it could be an equation. So it could be, let's see. So it could be an equation or a table that's used to predict the probability of a certain outcome, right? So let's say that we had this table, and this is the number of, I don't know. Let's say number of people um, that pass an exam. We'll say exam one. So I'm going to use a table to start off. So you'll have the number of people here. So we have 0, 1, 2, 3, 4. We'll just say this is like the world's hardest exam and hardly anybody could pass. And then we have the probability over here. So let's say the probability that nobody passes. I'm just going to fill these in. So let's say this is 0.2, 0.1, 3, 0.2, 0.25. What does that put me at? 575. 0.13, 0.12. Oh, 0.12. All right, so there's a couple requirements for a probability distribution. Is that in this column, you have to have numerical values. And then on the other side, if I was to add up all these numbers here, or sorry, all these probabilities together, it should add to 1.00. Sometimes you'll have an issue because you'll have like an issue with rounding or something, and it'll be like really close, like 0.99 or 0.98, and that's okay for the most part, as long as it's a rounding error or something. But they should always round to or add to equal 1. How you can use that then is, sorry, I need some like background music. How you can use that is they say, okay, find the probability that one person passes. So to find the probability that one person passes, I just look at this row, right? The probability of 1 is equal to 0.1. Does that make sense? Yeah. The probability of 3. So find the probability that 3 people pass. Then, okay, I just look at this row, and that's 0.25. A couple key words that you'll notice from like chapter 5, they'll say, okay, find the probability that at least, um, say at least 3 pass. So if they say at least 3, then that's telling you that you're looking at the probability when the value is 3 or larger. So we're going to look at all 3 of these now. So the probability that x is greater than or equal to 3, you're going to just add those together. So 0.25 plus 0.13 plus 0.12. And that'll give you 0.5. And the same thing goes with at most. So if it was at most 2, then that'd be x, the probability that x is less than or equal to 2. So now, oh, I don't use that color. We already use that color too. Then now I'm going to look at 2 or less. So I'm looking at all of these. So I would add 0.2 plus 0.1 plus 0.2, and that would give me 0.5. All right, so there are, again, so you can use a table. So one of the earlier sections would have had you use a table to find the probability. Then there's also a binomial probability. I'm not going to spend a lot of time showing you how to use a formula. I'm just going to show you guys how to use, or I'll show you how to input it, but then we'll use Desmos for it also. And then The other is the standard normal distribution. So it's actually using a graph and finding the area under the graph to find probability. So um, in order for probability distribution, you can use an equation, you can use a table, or you can use a graph. All right, so the first example that I have here, we're actually using a graph. So what? That sounds like somebody that I'd like to ignore. Uh, so no. So this graph is, and I'll show you right now. So for a standard normal distribution, there's a couple requirements, right? In order for it to be a standard, that means that your mean is equal to 0 and your standard deviation is equal to 1, right? Normal distribution just means you have a bell-shaped curve. And so that's your graph, right? So that would tell me, okay, my graph looks like this. And the thing about this is that as long as you have a standard normal distribution, that graph never changes. So it'll always be the same. So in this case, if we want to find the probability that z is less than 2.45, then what we're going to do is find 2.45 on the graph. So plug in my computer 4,000. Sorry, where's my plug at? All right, so we would go from here. We know that 0 is in the middle. So 0 is here in the middle. Then we're going to find 2.45. So we'll say 2.45 is out here. It doesn't have to be exact because this is just for us. So that's 2.45. If you can read my chicken scratch, let me write that in English. So 2.45. From 2.45, I'm going to draw a line up to the graph. And then look at the problem. So it tells me that we want to find the probability when z is less than 2.45. So I'm going to shade all of this to the left of that number, right? Because every number less than 2.45 is going to be to the left of that value. And so now what we're trying to find is the probability is actually the same as the area under the curve to the left of 2.45. So that's what we're going to have to find. Hey, Marlena, can you watch the chat to see if people have questions? Okay, cool. Then we're going to go to Desmos. And let me share this. All right, so then in Desmos, remember it's just desmos.com. You're going to go to calculator. All right, and then we'll click on this button here. I'm going to go to functions and distributions. Can you guys all see this? Sorry, okay. All right, and then now we're looking at the normal distribution. So in the normal distribution, normally you would put in here if you have a mean or a standard deviation that's different from 0 or 1, but because the problem tells us that it's a standard normal distribution, then we don't have to worry about entering any of that in there. All right, so we're going to find what? Yes, let me pull it up on my iPad because I think it'll be easier for me to do it that way. You don't have to switch back and forth. All right, let's go back to the iPad. All right, so graphing calculator, and then functions, normal distribution. Okay, so the difference between a normal distribution will be any bell-shaped curve, right? So with that, your mean is always going to be in the middle, and then from that mean, you're going to um, either add standard deviations going either direction. In this case, it's a standard normal distribution. So the standard normal distribution means that you start with 0 in the middle, and then your standard deviation is going to be equal to 1. So that's how you know it's going to be standard. And so anytime that you have basically standardized the value, so like when they tell you find the probability that x is greater than, I don't know, 25, and you make that x into a z-score, which we're going to do later on, once you standardize it, then you're going to keep your mean and standard deviation at 0 because it's been standardized. Does that make sense? So when you're plugging stuff into that z-score formula, the purpose of that is to standardize it so you can use it, treat it as a standard normal distribution. Does that make sense? Yeah. Okay. All right. So then we want to find the cumulative probability. Okay. So then the tricky part here is to figure out whether you have the minimum or the maximum. So in this case, we have 2.45 here, and then we shaded everything to the left of that, right? So because that's going to go on forever, then we leave the negative infinity part, but the largest value we could reach is 2.45, so we're going to change that to 2.45. And so we change that, and then that's our probability. Does that make sense? What? The probability is the area that's underneath the graph. So that's what we're trying. That's why I shaded all this part to figure out that's the area that we're looking for and that we need to calculate. And so if we use this in Desmos, it'll actually calculate that area for us. Yeah. Right. So the probability is 0.9929. There is. I'm not sure how to. You can Google it, I'd imagine. But I know they have a normal distribution function. I'm just not sure how to do it. Yeah, yeah, you can find them there. You can use a table. It just depends on your instructor, but you can use it. You can use a table or a calculator. Yeah. Cool. All right. Okay, so then for number 2, same idea, except for this one, we now want to be greater than 1.85. So from here, we make our graph. Zero's in the middle. 1.85 is here. Oh, sorry, I'll make this bigger. 1.85 is there. So then we are going to shade to the right of that. So we want the probability that z is greater than 1.85. Oh, I didn't mean to do that. And then we do the same thing. So normal distribution. Jennifer, are you okay with the chart, or do you want me to show you how to use the chart? I can show you. It's not a big deal. You sure? Okay. So that would be, oh shoot. Oh yeah, so now this is the minimum because that's the smallest number it could be. So it'd be 1.85. Oh, 5. And then hit enter, so then that's going to be our probability. So it's going to be equal to 0.0322. This is chapter 6 for you. Any other questions? Yes. For the table, yeah, that's what you do. Here, I'll show so everybody can see it. It's positive. Wait, I don't that one. So, shoot. That's not the right one. All right, so we would, what was it, 1.85? So you'd go over here to 1.8 and then over to 0.5 and just line them up like you would for a timetable chart. So it's 0.96. So the probability that Z is greater than 1.85 is going to be 1 minus 0.9678. And then that would give you the same result that we got. Is that everybody okay with that? Yeah. Okay. For number 3, you're actually going to work backwards. So for both of these questions, we were given a z-score, and then we had to find the area underneath that. But this time they're actually going to give us the area, and then we'll have to use the area to help us find that z-score. That's really ugly. So we have this. So then here, let's see. All right, so in this case, the area there, we're going to convert it into a decimal. So instead of being at 85%, it's going to be 0.85. And we'll say 0, 0. We're just adding 2 zeros on, so it is uniform with the actual table. And then we want to find z of 0.8500. So what you would do if you're using a chart is in the chart, you're going to look for 0.8500 in the body of the chart, because everything inside the chart would represent areas. Everything on the outside of the chart would represent your z-scores. So you are going to look for 0.85. And it's in between 2. So usually I tell my class to just go with whichever value it's closest to. So 1, if we're using the chart, shoot, I don't know why this is messing up. So it'd be 0.104 or 1.04. Does that make sense? Like if it's directly in the middle, then it'd be a little bit different, but it's closer to 0.8508 than it is 0.8485. You okay with that, Jennifer? What's wrong? Well, you could subtract it, right? So just take 0.8500 minus 0.8508, and then 8500 minus 0.8485, and see which one has the biggest difference. So whichever one of those differences is smaller is the right one. Because if I subtracted this one, it'd give me like 0.0008. If you subtract here, it's 0.0015. So this would be smaller, so I go with this one. Does that make sense? So the other way to do it to get an exact value would be to use software. So we'll use Desmos. Okay, so this time we're gonna use the what is it? Inverse CD. Oh shoot, I don't want to do that. Yeah. Inverse CDF, and then a normal distribution. Wait. Hold on. That's not right. Give me a second. Hold on. This is not right. Let me fix this real quick. Oh, shoot. Oh, here we go. Sorry, I spaced out on this. Let me find it real quick. Okay, so let's see. So we go here. So normal distribution. Wait. I'll just exit. So functions, normal distribution. We're gonna go 0 to 1. Oh man, I'm messing this one up. Let me see. What in the world? Hold on. Okay, let me see. Let me try this again. So normal distribution. Okay, there we go. All right, so here's how we do it. Sorry, I completely spaced on how to do that. And let me go back to my shared screen. All right, so you're going to go, let's start this over. So in functions, you're going to go functions, and then you want your mean and standard deviation to be 0 and 1. So you're going to go 0, comma 1. And then period, so or decimal, and then you're going to go functions, and then inverse CDF, and then put in the percentile that they gave us, which was 85. Yeah, that's what I see the problem. So, hold on, I'll go back to it right now. One sec. Is it frozen? It is frozen. Oh shoot, it is frozen. Holy cow. I need to upgrade my Wi-Fi. Let's try this again. Alright, there we go. Alright, there we go. So now it's fixed. Alright, so you're gonna go, let's do it one more time. So you're gonna go functions, normal distribution. and then 0, comma 1, and then decimal, and then functions. And so remember that normal distribution is always going to be 0, 1, 1, unless you're specifically told otherwise. Inverse CDF, and then you're going to enter your percentile. So it's the 85th percentile, so 0.85. And so that gives me my z-score. You guys cool with that? You're working backwards, so you're using the area to find the z-score. So normally we use the normal distribution, it will give you the area, but we want to work backwards to find the inverse. So that's what that's for. That's the function in the functions table. Yeah, so that's the function that we're using to find the area, or sorry, the z-score from the area. So the idea is we're instead of taking the z-score and then finding the area, we're working backwards, right? So because we're working backwards, it's basically like taking the inverse, right? We're going backwards from the area to find the z-score. So that's the idea. That's what I mean. Yeah. You're going to round to 2 decimal places, you're right. So it'll be 1.04. So z-score, you're always going to round to 2 decimal places. All right, so we're gonna do more of these. It'll just be more like an application-based problem. So we'll be able to use those functions again. I'm gonna go to number 4. So 4 is going over a binomial probability. So it's a binomial probability distribution. All right. And so for that, there are kind of a few things that tip you off as to when to use this one. So when to use a binomial is they will give you a total number of trials, and they're going to be given a probability. There's also a couple of requirements. So the first one, you have to have a fixed number of trials. Second is that the trials are independent. Third, what's third? Two outcomes. Thank you, Karen. Do you remember the last one? Yeah, for probability of success. Dang, Jane, why'd you hop in a long time ago? Success is the same for every trial. This is chapter 5, yeah. All right, so those are your four requirements for a binomial. So you have to have a fixed number of trials. So in this case, you have 50 trials because there are 50 questions. The trial is going to be independent, so the probability of you getting one question um, right or wrong is not going to affect the probability of you getting another question right or wrong. Um, Third, you have two possible outcomes. Your two possible outcomes here would be either you get the question right or you get the question wrong. And then fourth, the probability of success is the same for every trial. So your probability here is equal to 0.2. So our probability of success is going to be the same, right? Because you have basically 5 possible choices. Um, so if you want to screenshot that, then go ahead and screenshot that real quick because I'm going to have to erase it so I can do the problem. All right, so then if we have a binomial distribution, there's a couple of things we know. So we know that to find the mean, we can multiply the number of trials times the probability of success, and that will give us the mean. And to find the standard deviation, you take the square root of n times the probability of success, and then I'll just do it this way. And then 1 minus the probability of success. So that's what they want us to do here for this example. So we want to find the mean and the standard deviation. So I'm going to get rid of this. Yeah, 1 minus p is also the q. Yeah. All right, so what we're going to do, first we want to list out all our information. So we have n is equal to 50, p is equal to 0.2. So for our mean, we're going to take 50 times 0.2. And what does that give me? So that'll give me 10. Then the other way, we're going to go the square root of 50 times 0.2 times 1 minus 0.2. And then that will give me my standard deviation. And that'll give me 2.83. Thank you. All right, so we've accomplished what we wanted to for this part. So we wanted to find the mean and the standard deviation. Everybody okay with that? Yeah. All right, so then from there, so if you remember from last time, we used, hold on a second. So assume the following binomial distribution. We want to find the range of usual values. So the usual values would be like the normal range of test scores. So to do that, if you remember, we have the range rule of thumb. And we used it last workshop that we had, rule of thumb. Which pretty much said that our usual range of values is the mean minus 2 standard deviations and the mean plus 2 standard deviations. So for our minimum usual value, you're going to take the mean. So our mean we found up here, our mean is 10 and our standard deviation is 2.83. So we have 10 minus 2 times 2.83. And then our max is going to be 10 plus 2 times 2.83. And that will give me 15.66. So what you could say for this is like if a person had no idea what they're doing and they're just going to guess, um, they should get scores between 4.3 and 15.66. And then anything outside of that would be considered unusual. You okay with that? What? What 20? Oh, that's the symbol for standard deviation. Yeah, it's a sigma. You're good. All right, so that's kind of just to review the concept. So then we'll go on to like some applications. So I'm going to start with some that have to do with chapter 5 first, and we'll kind of work our way back. Or the binomials. Let's see. Okay, so let's look at number 8. Okay, so for number 8, let's look at what we have. So they tell us that workers cited 17% of firings. Companies' working conditions. Investigate 5 employee firings that occurred over the past year. Assuming that the 17% rate applies, find the probability that at least 4 of those 5 employees were fired because of an inability to get along with others. Alright, so this is the information that we're given. So we have a 17% rule. So 17% said that inability to work with others was the reason they were fired. Then we want to find the probability of 4 out of 5. So we're going to check our criteria for binomial. First was, do we have a fixed number of trials? What do you guys think? Is there a max number of like firings that we're looking at? Yeah, 5, right? So that checks. And so we'll say n equals 5. Second, are those trials going to be independent? So does one firing affect another firing? Shouldn't, right? Okay, so that will work. Third is, do we have 2 outcomes? What do you think? What are they? Fired or not fired, right? Either you got a job or you don't, right? So that works. And then fourth, is the probability of success the same for every trial? So in this case, success would be firing somebody. So is that probability the same for everybody? Or are we told that it is the same? What do you guys think? What do you think? Why? Well, based up, so we're not assuming anything, right? Just giving off what the information that the problem gives us. So what is the rate of firings that are due to inability to work with others? 17%. So that's the same, right? Okay. So now we can use our binomial rule, which was the probability of x is going to be, and choose x, p to the x, and then q to the n minus x. So that would be the formula we would use for that. So I'm going to show you guys both ways. Okay, so what we would do is we need to figure out all of our information. So we need n, and then remember q is also 1 minus p. So n is going to be the number of trials, and there are 5 trials. X is going to be the number of successes. So it'd be the number of people that were fired because they had an inability to work with others. So what would our n be? Or sorry, x be? So it'd be 4. Is that it? So make sure be very careful when you're reading these. So kind of the tip off here is it says at least 4. So because it says at least 4, that means what? There you go. So it's going to be x is greater than or equal to 4 and 5. Because we're going to have to do whatever we're going to have to do, right, Gabby? Yes. And then, so x has to be greater than or equal to 4 or 5. So we need to do both of those. So I have x greater than or equal to 4. Your probability of success is going to be 0.17. Your Q is going to be 1 minus 0.17, which is 0.83. All right, so now we are going to plug all that in. So now what we're going to have to do is, because we need to find the probability of 4 and 5, is we're going to have to basically plug everything in twice. So we'll have to plug it in once for 4, and then we'll plug it in again for 5. So we're going to have the probability that x is greater than or equal to 4, not 5. And now I'll put it in a bracket. It's going to be 5 choose 4. 0.17 to the 4th power, and then 0.83 to the, what is it, 5 minus 4. So that's just for 4, and then we need the same thing for 5. So 5 choose 5, 0.17 to the 5th, 0.83 to the 5 minus 5. You guys okay with that? What's up? Well, can I show everybody how to use the formula first, Gabby, before you get all demanding? I know. No, I got you. But not everybody has to do it this way, though, so that's why I'm showing you this way first. Yes. So all I'm doing is I'm taking these values and plugging them into the formula. So this first one is when x is equal to 4, and the second is when x is equal to 5. And then we're going to add those two together. So let me show you how. So if we're going to do it longhand, I'll show you guys both ways. So longhand, we would go functions and then stats. So NCR, we're going to go 5, comma 4, and then times, and then we're going to have the rest of our stuff. So it's going to be, where is it at? Uh-oh. Oh, maybe we can't do it here because there's no, let's see, exponents. I don't know. Let's see, we'll go here, and then it should be a caret or something. No, I don't see it. Alright, so here's what we'll do. Okay, so we can go to distributions, and then binomial distribution. And then you're going to enter in the number of trials and then the probability of success. So here the number of trials is going to be 5, comma comma, your probability of success. So our probability of success is 0.17. So 0.17, and then hit enter. And then what it'll do is it'll give you a graph. All right. And then each of those dots represents the probability. So here, the probability that 0 firings is 0.394, 1, and then you have all the way 4 and 5. So there's 4 and there's 5. And then those are the two that we were concerned with. The issue here, so we have for 4, this will give me 0.003, and then plus 0. So the only issue with Desmos is that it doesn't go to like some of them will go to more decimal places, and you'll have to use exponentials. So let me do this in my calculator. So we're gonna go PRB NCR. So 5 NCR 5 times. You said what? Oh, you have them? You have 4? Zero. Wait, 0.003466. Okay. Alright, and then what about the other? 86. Alright, and then we would add those two together. One more time. 0.03. Uh-huh. 08. Alright. Okay. Alright, and that would give us 0.0036. Right. So then that's one of the limitations that Desmos has, is that when you have a value like this, it always rounds it off to 3 decimal places. So that's one of the limitations that we have. All right. So yeah, you can plug this in your calculator, and that'll give you that result. I think on a TI, you're able to do that also. Mm-hmm. 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 Oh, it's right there. It's the blue arrow. Oh, yes. So if you look at the graph, you'll have to move the graph around to get to where the dots are. So just make sure you're like right at the origin. You see it? You got it? Oh no, it's blurry. What? Uh-huh. Yeah. Oh, okay. So something was wrong. So you hit. So here. So go binomial distribution, and then 5. Did you add a comma in between the 5 and the 0.17? Did you add a space? Yeah. Yeah. So it shouldn't be a space. And just hit enter. Okay. Yeah. I don't know, Jennifer. Okay. Are there any questions on number 8 though? Or questions like number 8? Uh, yeah, I don't have the TI-84, but it should be under the probability function. Okay, so that's a good question. Usually, I would pay attention to your directions. Most of the time, you're going to round to 3 significant digits. So, like in this one, you would round here. So it'd be 361. But if they ask you just to round to 3 decimal places, then this is 3 decimal places. So this would be your 3 significant digits, so you don't count the zeros. Um, but if they ask you to round to 3 decimal places, then you'd have 0.03. 003. 3 decimal places, okay. Yeah. Okay, so let's see. Let's shoot, we're way behind. Let's go up to this one. No. Yeah, let's go up to number 7. All right. So for number 7, first let's look at this. So if you look at number 7 and 8, like side by side, do you guys notice a difference in the two problems? Because remember, one of the things with the probability section is that you need to be able to figure out when to use which type of probability. So you can kind of look for key words or key concepts that'll help you figure that out. So do you guys see anything different between number 7 and number 8? Okay, so there's decimals. Anything specific about those decimals? They're in inches, yeah. So yeah, so you're given a mean and standard deviation. And then over here, we weren't. We're given a you're given a probability of success. So that's kind of one of your tip-offs, right? So for binomial, use that's my first thought is okay, if they give me a percent of success, then I'm going to check to see if it's a binomial. Um, and also the fixed number of trials. So the fact that you have 5 total trials. Up here, they gave me a mean, they gave me a standard deviation, and then they told me that it was normally distributed. So that tells you that you're going to use the standard normal distribution. All right, so that's kind of, I don't know, just to look for, and if you find other things that kind of help you decipher when to use each one, then that's fine. Just always look for like keywords or key concepts that tip you off as to which method to use. Okay, so in this one, if we're going to use the standard normal distribution, they want us to do what? So we have the girls have heights requirements. It must be between. So these are our 2 height requirements. Given that the heights of women are normally distributed with a mean of 63.6 and a standard deviation of 2.5, we want to find the percent of women that meet this requirement. So we would start off, we want to find the probability that these heights are between 66.5 and 71.5. So that's what we're starting off with. So the idea is that we're kind of looking at a graph. I'll just draw the graphs below. So we know it's normally distributed. Remember that your mean is always in the middle, so you have your 63.6 here. And then you have, here's your 66.5, and then 71.5. And we want to find the area that's here. All All right. So what we can do to help us is we basically standardize that. So we take those two values, the 66.5 and the 71.5, and we can turn them into z-scores, and then we can use our z-score chart or Desmos. So I'm going to take 66.5, and let's write that z-score formula. So your z-score formula is, I'll put it below. So z is equal to x minus the mean divided by the standard deviation. Oh, it's like that. Okay, so I'm going to use that for both. And so we'll do them in different colors. So when x is equal to 66.5, you're going to have the mean is equal to 63.6. And then your standard deviation is going to be equal to 2.5. So we substitute those values into that formula. So we have z is equal to 66.5 minus 63.6 divided by 2.5. And that'll give us what? Divided by 2.5. And that will give me 1.16. Is everybody cool with that? Yeah. All right. And then we do the same for the other value. Was that a question? No, we're good. Okay. All right. So then for the other, the 71.5, so we have x is equal to 71.5. Our mean is going to be 63.6. Standard deviation is going to be 2.5. So z is equal to 71.5 minus 63.6 over 2.5. And that will give me 3.16. So those are, so now we've in essence standardized those two values. So now our graph, we're looking at this. So we want to find the probability that z is between 1.16 and 3.16. So your chart now looks like that. And remember, zero's in the middle. You have your two values, so you have 1.16 and then 3.16. And we want to find the area in between. So I'm going to show you guys how to use the chart first, and then I'll show you guys how to use Desmos. All right, so what we're going to do first is you want to find 3.16 in the chart. So we're going to find the area. So we're going to find the total area all the way over. And that'll be the 3 point. You said what? Let me see. Let me find it real quick so I can show everybody. So 3.16, you can go 3.1 and then 0.6. So 0.9992. And then you're going to subtract out the part that we don't want. So subtract out from 1.16 over. So I find 1.16. So I have 1.1 and then 0.6. So give me 0.8770. And that'll give me 0.1222. All right, so that's how you would do it using the chart. If you were to use Desmos, then you would go, so functions, we want the normal distribution. We're going to keep that the same. Find the cumulative probability. So now, instead of having the min and max be infinity and negative infinity to infinity, we're going to change it because our minimum value is 1.16, and then our maximum value is 3.16, and then that would be our answer. Does that make sense? Yeah. Yeah. Yeah, I'll go. Is everybody okay with how to use Desmos for that? Yeah. Yeah. Okay. Well. Mm-hmm. All right. So then this application part just asks, does it appear that Laker girls are taller than most women? So how do you think you can respond to that? Any ideas? Yeah, whatever. So, the idea is this, right? We know that the mean height is 63.6, which is right here in the middle, right? So that's most of your women. Do you guys remember what the cutoff was for z-scores, where something like a usual height or unusual height? Do you remember that? Less than -2, right? So if it's between those two, then those are your usual values. So between -2 and then your +2 would be here, right? But still, just the fact that all those women are above the mean, and then there's only 12% of women that meet that criteria, will tell us that yes, it appears that they're taller than most. Because that's what? How tall is that? 66 inches. 5'5". 5'5" to just over 6 foot. Any question on how to do number 7 though? Are you guys okay with that? Oh no. So what we say for that? Did you have any ideas at least? Yeah. What do you think though? So because this probability is 0.0003, do you remember the cutoff? So okay. So yeah, so when you're dealing with z-score, the cutoff is between 2 and -2 for it to be usual. And then with probability, it's going to be 0.05. So that's less than 0.05. So it'd be unusual, yeah. So it'd be unusual for 4 or 5 firings to 4 or 5 firings to have occurred. Um, so we would say no. This company does not appear to be different. The probability at least 4 firings. It's 0.003. Try to see. Okay, so let's look at number 9. So number 9, what do you guys think we should do? So first read it and then figure out, okay, is it going to be binomial or would it be a standard normal distribution? Dang, can you give people a chance to read it, girl? Okay, so standard normal. Why standard normal? So they give us a mean, they give us a standard deviation, and what else? One other key term. Normally distributed. So those are kind of the key things you're looking for, the 3 key things you're looking for in those. Okay, so all right. So for number 9, keep jumping a little bit. We are going to start off with that. Then we want to find the probability that 25 randomly selected women have a mean pulse rate between 70 and 85 beats per minute. So we want the probability that X is between 70 and 85. So we're starting off like this with our 77.5 in the middle. 70 here, 85 here, and we want to find the area between these two. Can anybody see how this problem is different than number 7 that we did earlier? How? Yeah, so the 77.5 is in the middle of 70 and 85, right? So we're not off to the side of the mean, so we're on each side of the mean. Anything else, like in the wording of the problem? Right, so in this time, we're looking for a group of 25 women. In the problem before, it didn't even tell us. We just assumed we were looking for 1, right? So when they give you a group size, then how we find the z-score is different, right? So I'll put both down here. So normally we would go z equals x minus the mean divided by the standard deviation, right? When we have a group, what we do is called the central limit theorem. Is what we use. So now we're going to go, okay, z is equal to x minus the mean over the standard deviation divided by the square root of n. So it's pretty much the same, aside from the fact that we have a group, so we are, oh, no, I didn't write that best. Yeah, this is 6.4. Yeah. Okay, so in this case, the 25 is going to be our n. All right, so now we're going to do the same thing that we did in the last problem, but because we have 25, then we also need to take into account what our value for n is. So we need to standardize both values. So first we're going to standardize the 70. So we'll have, what is it? X is equal to 70. Mean is going to be 77.5. It's going to be standard deviation is 11.6, and then n is, what is n? Oh, I got 25. I said it like 5 times and I already forgot. All right, so we're going to plug all that in. So z equals 70 minus 77.5 over 11.6 divided by the square root of 25. Oh, shoot. All right, and that'll give me negative 3.23. And then I'm going to do the same thing for, I like blue better, 85. So we'll have x is equal to 85. X bar is going to be 77.5. Sigma x bar is going to be 11.6. N is going to be 25. So we'll have z is equal to 85 minus 77.5 over 11.6 divided by the standard deviation, or sorry, square root of 25. All right, and that'll give me positive 3.23. All right, so now we've standardized them, and we are trying to find the probability that z is between those two. So negative 3.23 and positive 3.23. Ugh. Ugh. 2, 3. Everybody cool with that? Any questions so far? Are we okay? So now what's our next step? And what are we looking for first? Positive first, so the larger the two numbers first. So we're going to go 3.23 first, and we're going to find all that area. What do you get when you look that up, Jennifer? 9994. And then minus, then we're going to subtract out the smaller of the two. So we're going to subtract out negative 3.23. Red. What did that give you? All right, and then plug that in your calculator. I'm trusting you right now, so it better be right. Yeah, that's right. So 0.9988. All right, so that's that. So in decimals, you would go functions, normal distribution. Again, we standardize it so we can leave it. Find the cumulative probability, and then we'll go negative 3.23 for your minimum, positive 3.23 for your maximum, and then that's our answer. So it ends up being the same. You guys okay with that? Okay. Okay, so that's that. All right, what about number 10? What do we do? Why? So it gives you that there's 24 selected people, and then part B, there's 20 selected people, right? So then that's when you would go through your good requirements for binomial. So we need to see, okay, is there a fixed number of trials? That's first. Yes, because there's 24. So that's our first check. Second is what? Are they independent? So each person deciding to use a tax preparer would be independent. 3, are there 2 outcomes? What would the outcomes be? Or they didn't, right? That's it. So then that's that. And then 4, is the probability of success the same? So our probability is 0.48. So that's that. All right. So now we have to do for this one. Among 24 selected adults, at least 21. So what is at least 21? Well, let me put everything down. So we have N is going to be, we said what, 24. All right. And now X, it says at least 24. Sorry, at least 21. So what does that mean? In terms of... So if I said I have at least if I said I had at least $20 in my pocket, you would say, okay, he has at least 20 is the minimum number he's gonna have, or he could have more, which is true because I normally don't walk out of the house with anything less than like 10,000. So like, that's normal. So yeah, I mean, who does it? So X is gonna be greater than or equal to 21, which tells us that we need to find X equal to 21, 22, 23, and 24. Ooh, this is a nasty one. All right, so then your P is going to be 0.48. And then your Q is going to be 1 minus 0.48. So that'll be 0.52. And we're just going to plug everything in. So it's just going to be rather long. So we'll have the probability that X is greater than or equal to 21. So first we're going to go with 21. Oh my goodness. 24. Sorry. Wait, don't do drugs, guys. Let me run this back. So we need the probability that x is greater than or equal to 21. So we have, do 21 first. So 24 choose 21 times 0.48 to the 21st, 0.52 to the 24 minus 21. Right, and so that's just for when, I'll put above it, this is when x is equal to 21. Plus, I'll do a different color. 24 choose 22. Then you have 0.48 to the 22nd, 0.52 to the 24 minus 22. And that again is for when, this is when x is equal to 22. Then 24 choose 23, 0.48 to the 23rd, 0.52 to the 24 minus 23. And that's when x is equal to 23. And then the last one, 24 choose 24, 0.48 to the 24th, 0.52, 24 minus 24. And so you're going to plug all those in. I think I have to do them all separately. So I don't know. Jane, do you have any of those yet? Okay, let me see. So let's try to use it. Let's use. Let's use Desmos. All right, so we're gonna round to 3 decimal places. So we're gonna use Desmos. All right. All right. Good talk, guys. Thanks for the affirmation. I appreciate it. So we're gonna go number of trials. So that's gonna be 24. And then our probability of success is going to be what? 0.48. And then we hit enter, which is also known as the blue arrow. And then she's not even paying attention to me. That's cool, Jennifer. I see how it is. All right, and then we find those 3. So we need, what do we need? 21. So there's 21, 22, 23, 24. All that work to get 0, 0, 0. Plus 0, plus 0, plus 0, plus 0. The only reason why that'd be okay is because we said initially that we're rounding to 3 decimal places, so that would give us 0. But if you were to put those in your calculator, because those are really small values, let me see what I can get for you. So 24, choose 21 times 0.48 to the 21st times 0.52 to the 24 minus 21. Yeah, so this first one would give me I'm just gonna write it right below. I'll write it in red so it'll look different. The first one gives me 0.0000 1, 2, 3, 4, 5, 7, 5, 8, 2. All right, so all of these values are going to be really small, and then I'll do the other one. So this is 2. Change that to a 2. 2. This one here will give me 0.0000. What is that? 1, 2, 3, 4, 5, 7, 2, 4, 8. Then the same thing for 23. And then this one is 0.00. 1, 2, 3, 4, 5, 6, 5, 8, 2. And then the last. Oh, it's about time. Just kidding. What'd you get, Jay? 22. Cool. Yeah, so you can see if you were asked to round to 3 decimal places because your first 3 decimal places were always zeros, then your answer would be 0. And this is actually one of the problems that a lot of people get wrong on my homework assignments. They'll put, I don't know, they'll try to do 3 significant instead of just doing 3 digits. Everybody cool with that? Well, oh, so if you look at these, and all these, sorry, when we input these values into the calculator, uh, if we're rounding to 3 digits, those first 3 digits are always zeros. So it makes sense that my result would just be 0. If we were doing 3 significant digits, we wouldn't look at those first 3. We would end up looking past that to this part, right? So then your answer would be different. So it just, again, depends on your rounding rules for it. Does that make sense? Yeah. Okay, so what do you want to do? I'm going to give you guys like 5 minutes to try part B. Not even 5. So I'll give you a few minutes just to get started on it, and then I'll kind of pick you up and then figure out which method to use, and then start it. And I promise it won't take as long as we did for number 10. All right, so what do you guys think? So we know it's binomial, right? Right. I said, so what do you guys think? So we know it's binomial, right? And then what do we do from there? Right. So what did you guys get for n? Whoa, whoa, whoa. So n is going to be 20 because now you have a sample of 20. What about your x? Mm-hmm. What about your p? 0.48 still. And then your q would be 0.52. So that's going to stay the same. So one way to figure out if you have an unusual value is to find the probability. The other way is to remember what we did before which probably would be the best way to do it in this case. For number this problem for number 5 or 4 and 5 actually. So we found the mean and the standard deviation, and then we used the range rule of thumb. And then if it was on the high end, then we know it's unusually high, or if it was on the low end, we know it's unusually low. So let's do both. So let's find the probability first. So if we do, okay, the probability that of 12 is going to be 20 choose 12. That's not a 20. And then 0.48 to the 12th, 0.52 to the 20 minus 12. Whoa. Oh, you got it? Yeah, what'd you get? Yeah. Yeah, 0.007 36 703. All right, so then if we rounded that, that would give us 0.101. All right, and then what we're looking for, in order for this to be unusual, so it's unusual if your probability is less than or equal to 0.05. So in this case, that number is, or our probability is greater than 0.05. So we would say no, 12. Let's see. No, we'll do this. That'll sound better. So we'd say in the sample of 20 adults, it is usual for 12 of them to use a tax preparer. Does that make sense? So if this number, when we found the probability, if that was less than 0.05, then we would, then we know it's an unusual number, and we can use that range rule of thumb to figure out if that is an unusually high or low number. But because 12 is greater than 0.05, it's not going to be significant, so that means this, it kind of fits the mold of what we see before. You okay with that? Okay. We're short on time. Let's see. What's the last one? Okay, we got time. Okay, so for number 11, what should we do? So part A, we want to know what percentage falls in the category. And then you said it's standard normal. Why would it be standard normal? Mean, standard deviation, and normally distributed. Right. It's actually before that, but it's okay. Oh. You're good. All right, so part A, we want to what earthquakes with magnitudes less than 2.0 are considered micro earthquakes? So what percentage of earthquakes fall into the micro earthquakes category? So we want the probability that X is less than 2.0. So we're looking at our graph. We have 1.184 here. Oh, that's a bad color. 2.0 falls here. So we're looking at everything to the left of that because it's less than. So we're going to standardize it. So, and notice that it doesn't tell us a number of earthquakes, right? So we don't have to worry about it being a group. It just says earthquakes with magnitude. So we're just going to treat it as being a single. So we'll have X, then we need our mean, and then we need our standard deviation. So our X is 2.0. The mean is going to be 1.184. Standard deviation is 0.587. And we're going to plug all that in. So it's 2.0, 1.184, and 0.587. And that will give me 1.39. Everybody cool with that? Yeah? Alright, so then our next step, we're going to standardize. So we standardized it, so now we have the probability that Z is less than 1.39. Awesome. Alright, so we would look that up in the chart or go to Desmos. Oh shoot. So this one. And we're gonna go normal distribution, find cumulative, and then that 1.39 is gonna be our maximum. Alright, and that gives me 0.9177. Everybody cool with that? Yeah, so in this one, remember the one where we changed both values was when we had to find the area between two numbers. In this case, it's just less than. So with it just being less than, you shade from 2 and then on, but there's no stopping point. So your minimum is going to be that negative infinity, and it's going to go to 1.139 or 1.39 as your maximum. All right, then. So that's that part. Everybody cool with that? Ish. Okay, and then for number 10, so earthquakes above 4.0 will cause indoor items to shake. So what percentage fit into that category? So now we want above 4.0. So probability that X is greater than 4.0. We still have the 1.184 here. 4.0 is here. And we're shading to the right of that because it's above now. Same thing though, we want to standardize it. So we have X equal to 4. The mean is going to be 1.184. And then 0.587. Substitute those values in. So 4 minus 1.184 divided by 0.587. That'll give me Z equals 4.79. Actually, it's 4.80. You round it. 80. Then same thing. So now we want to find the probability that z is greater than, or equal, oh no, just greater than 4.80. So in decimals again, functions, normal distribution, leave that. Now 4.80 is going to be your minimum. Hold on. Try this again. Oh. No, that's right. All right, so you're gonna have to go. So this is gonna be 1 minus, and then what we get in the chart. I don't know why it's doing it this way. 1, 2. So you have to move the decimal place over 7 times. And then 793. So that'll give me 0.99999. 1, 2, 3, 4, 6, 2, 0, 7. So that would be your answer for yeah. So for in decimals, it gave me the 7.93 and then times 10 to the negative 7th. So that would just mean that I moved the decimal place over 7 times. So that's how I got the 6 zeros and then 793. Does that make sense? Oh, shoot. I'm tripping. What? How I got the z-score? I'm tripping. Yeah. Oh, okay. So you're 7 points. Dang, I'm tripping. Okay, let's start this over. All right, so when I plug this into decimals, it gives me 7.93 3, and then times 10 to the negative 7th. All right, so that's scientific notation, right? So you have 7.93 times 10 to the negative 7th. So that just means I'm going to move the decimal place to the left because it's negative 7 times. So 1, 2, 3, 4, 5, 6, 7. So 0, 0, 0. I don't know. So we end up with 0.00. You can't see yellow. I can't see that. What do we get? 0.000000793. And then remember, this should be really small because it's greater than, or what? Because our z-score is 4.8, so it should be pretty small. All right, and then the last thing, so find the 95th percentile. So I want to show you guys how to use decimals for that. That's kind of a quicker way to do it. And so we have your mean is what is our mean? 1.184. Your standard deviation is 0.587. And then in this case, we want to find the 95th percentile. So P is equal to 0.95. So in decimals, what we can do is go, okay, so we did, before we said, okay, we're going to go functions, and then normal distribution. So I'm going to change my mean and standard deviation to what I have listed here. So 1.184. And then my standard deviation is 0.587. And then period. And now we're going to do the inverse, because remember they gave us the percentile, so we need to work backwards to figure out what this data value is. And so we go inverse CDF and then 95 percentile, so 0.95. And then that's your value. So 2.15. So if you remember, that was similar to the one we did before when I was kind of struggling trying to figure out what that value was. But that's how you would do that one. And then so instead of a lot of times it'll give you the z-score, and then from the z-score you have to take that and find the x value. Instead, if you use Desmos, you can just go straight from the mean and standard deviation straight to the x value. Somebody was saying something. Yeah, so use the inverse when they give you the percentile. Exactly. All right, so we are out of time. But Marlena put the link to the survey. So if you guys could fill that out before you guys leave. And if you guys have any other questions that you want to go over, I'll stay on for a while. And so will Marlena. But otherwise, we'll see you in a couple weeks. What's up? You always have questions. What's up? Well, because it's not set just for our class. It's set for all stats classes. So we're not necessarily all at the same place. And some of them are just giving big tests rather than like we do. So it's not all about you, Tierra, okay? It is. What's up? Yeah, we're going to have one this Wednesday. We just had a holiday this Wednesday, so that's the only way to have it. Yeah. Okay. Yeah, we'll definitely have one this Wednesday. That one's just for my class. It was my normal class meeting. Yeah. Whose class are you in? You're fired. You're welcome, Irene. Those review sessions are just for my class. So that's my regular class meeting. Yeah. You're welcome.